So I wanted to communicate some concepts related to Gaussian splats, or Gaussian splats, depends how you say it, compared to photogrammetry resulting in meshes and point clouds. And I wanted to explain it in terms of typical industrial scenes where there might be some complicated geometries, piping or hardware and equipment that you don't get in many photogrammetry examples where, like in a room or a building, there are large broad surfaces that photogrammetry in particular looks okay, but when you start having these complex geometries, the textured meshes that result aren't as good as what you can get with Gaussian splats. So I wanted to demonstrate that. So I wanted to go to a location that has that sort of complexity. I was trying to think of some industrial sort of spaces like switch yards or sewage plants, but they don't have public access. So what I decided to do is go to my local park and the playground where I usually take the dog to the park for a walk or throw the ball. And playgrounds have equipment, play equipment that is, it's got convoluted spaces, railing and all that sort of thing. That's not your typical room level scene or outside building scene. So that's why I decided to do this as an example and a test. Now, what I could do is go through and take a whole bunch of photos manually or a video. Both have the problem of not knowing where you've been within the 3D scene. If it's a complex one, you're not sure what places you've missed. And so I decided to use an app called Pix4D. And what I'll do is just set this up, and then I'll share my screen and open one of the projects, which is the playground project. So the advantage of something like Pix4D as an app is that it keeps track of where you've been, and in your camera view, you can see like an animation of what aspects of the scene have been mapped. So it gives you a good idea of where you're at. And so this is an example of where I went through the playground. Each of these little blue rectangles is a camera photo. So I started from this side of the playground and went in a loop. Actually went down here, around, then looped all the way to get to the swing area. So the end result of that is a whole heap of images, like in this case 691 images. So this gives you a sort of feel of how many images you need to even get halfway decent Gaussian splats. And that's why typically if you just take manual photos, you often don't take the number of photos needed to do the processing. So that's what I decided to do. There are a few challenges because it's a public space. Fortunately, it was a point in time where there weren't many kids around, but I was cognizant of stopping kids from going in the playground. This guy's going around with a phone looking at the playground at all different angles. So I sort of rushed it because of it. But I suppose the message here is any scene you really want to have unfettered access and not give you rush, so you make sure you get the coverage you want, and in lighting conditions that are consistent, not too bright, not too dark, and nothing moving in the scene for the period during your scan. Now, I didn't have like a pole, so I could do some top level shots. If you note on the top of this scene here, my camera didn't get this as part of the shots because I was too short. Now, if I had a large pole, I could probably get more of that sort of coverage. Now, you still get some aspects of it because underneath, whoops, see if I can get it underneath. So one aspect of the app that was a bit, I suppose, disappointing is that it chewed up a lot of battery power. And you notice that the phone was getting hot, and this is typically due to high frame rates. Now, some applications we've implemented in the past, you actually tone down the frame rate when you know it's not needed. So this is particularly important for phone level apps. So that was a bit frustrating. You have to sort of manage the battery power on this particular app, so you've got enough battery power after you've finished the scan for other stuff. So now I use the Pix4D app, and that's an associated web app, which is cloud-based processing. And it's got a nice feature where you can actually show different representations of the scan. And this is really useful to show the weaknesses of something like point clouds. So I've checked the point cloud option, and it's slowly loading in the point clouds. And you need to load a lot of points to get even close to indication of realism. You can see it's still loading, and you get this grainy effect. So if you've got a 3D scene where you want to visualize and have some sort of realism, point clouds aren't really well suited. Now, another option is to use photogrammetry, which produces 3D meshes which are textured. I find them typically, for any scenes that are of reasonable complexity, have too many artifacts, which spoils the feel of realism. So I commonly call this the melted cheese look. So there's an example of the artifacts that get in the way. So unless you've got like large smooth surfaces that you don't have to go behind, I don't think photogrammetry is the answer. And Gaussian splats, if you get enough samples and you process appropriately and maybe do some post-editing of removing some artifacts, you can get high levels of realism. Now, this particular part of my path I did too quickly. If I did more of different aspects of it, it would be a better result. You can see it in these particular guardrails, a slightly better result. But when you have smooth surfaces, it looks pretty damn good. Even in the sand, looks pretty good. But I suppose with a scene of this complexity in terms of the fine-grained detail, my argument is you're going to get a much better feel of realism with Gaussian splats compared to photogrammetry meshes or point clouds, and better performance. There are other advantages to Gaussian splats as well, in that you can create objects like these little mushroom stools or whatever. Either you can do a scan of these individually and then edit out everything else and then reuse them, or you could take a scan of a scene and cut out in 3D the portions that you're interested in. This allows you to do things like, okay, if you want some sort of animation, this is a poor example because it's just a playground, but say you wanted an animation where these stepping stones were part of a game and they moved up and down, all the way up and all the way down. You could snip out in 3D each of one of these stepping stones and then animate those separately through movement, scale, colorization, that sort of thing. So it provides some options for more programmatic manipulation of the scene. Just as an interesting side issue, this particular Pix4D processing of the imagery, it didn't quite get the chains that hold these swings up and down, but in post-shot, which is an alternative application, its processing did successfully get the chains in the view. But this is another example of where you could 3D snip out the chain and the swing seat and treat that as an object that is rotated across a base point to simulate swings. Now, another advantage of Gaussian splats is you can use the scene, the realistic scene, as like your backdrop, and then add other forms, either splats themselves, as I've been talking about, or standard meshes, and mix and match the animation, providing a combination of realism and a programmatic generation of a game or a simulation. Before I move on, you might not be aware of what a Gaussian splat is. Splats are basically ellipsoids, so 3D ellipses, which have a combination of color, transparency, and shape. And if you zoom up, like, you start to see them. So if you can see that line there, that's an extended ellipsoid that's very white. And each one of these black portions will be other ellipsoids. And what the training does is it takes the images, let me see the images, and uses those as a goal, and says, defines an algorithm which identifies what's the optimal, within processing constraints, optimal set of splats or ellipsoids with different types of colors and transparency that would recreate each one of these images in terms of from a particular viewpoint and camera pose. So it's sort of like 3D painting with ellipsoids. Now, I mean, there are other triangles as well. There's a bit of a technical community being built up around Gaussian splats because of you get. Now, it's not something you can just like take a bunch of photos of a scene and press a button and everything's hunky-dory and perfect. Like, for example, you'd want to go through and edit out, like this part. I didn't actually take a decent set of photos for this piece of equipment, so it just did an approximation for it. Now, what I can do is edit out this from this scene and either go back and scan just that piece of equipment in isolation and put it back into the scene, but that's all involved a bunch of editing. So don't have too many expectations of low-cost workflow. To get higher levels of realism, you need to be quite pedantic and a bit of post-processing and post-editing, manual editing, and be aware of if you don't have a good picture in the image set, you won't get a decent result. For example, this I didn't have a camera angle looking at this from above. If I had a long pole on the day, I could probably just elevate the camera, the phone, to take this to get a better rendering and have it look more like the slide in terms of quality. So hopefully this gives you a better idea of what you can do with Gaussian splats and why for applications that need some sort of level of realism, they are a better option than point clouds, photogrammetry based textured meshes.